Hello everyone. Today I am going to talk about balancing chemical equations, a fundamental part of chemistry that ensures chemical reactions follow the law of conservation of mass. What is a chemical equation? A chemical equation represents a chemical reaction. It shows the reactants, the substances we start with, and the products, the substances we end up with. You can see here there is an example given. You have CH4 and oxygen reacting each other. So these are your reactants. They will react each other to form carbon dioxide and water. So in this reaction, carbon dioxide and water are the products. Why do we balance equations? We balance chemical equations to make sure we have the same number of each type of atom on both sides. Atoms can't be created or destroyed in a chemical reaction. This is called the law of conservation of mass. Let's look at the number of atoms in each side. In the reactant side, in CH4 molecule, you can see there is a 1 carbon atom. And there are 4 hydrogens and there are 4 oxygens from oxygen reactant. And in the product side you can see you have 1 carbon which is coming from carbon dioxide and 4 hydrogens which is from H2O. There are 4 hydrogens because there are 2 water molecules and 4 oxygens. 2 oxygens from carbon dioxide and another 2 oxygen from water. Total is 4 oxygens. So this chemical equation is already balanced. When you are balancing chemical equations, usually we write the unbalanced chemical equation and then count atoms of each element and use coefficients to balance the atoms. The coefficient here is in methane, you don't have anything written here, so we take it as 1. And in front of oxygen you have 2 here, this is the coefficient. In front of carbon dioxide there's nothing written, so it's 1. In front of water it's 2, this is the coefficient. When you are balancing chemical equations, you can only change the coefficients, so you can add the coefficients to balance the chemical equation. However, we are not changing the subscript numbers. If I tell you example, here you have H2O, so we cannot change this subscript 2. If you change that, another chemical compound called peroxide has this. So H2O2, if you change the subscript, it's completely changed the chemical compound. Therefore, you should not change the subscript, but you can change the coefficients to balance the chemical equations. Let's look at this chemical equation. Iron and oxygen will react each other to form iron 3 oxide. Iron and oxygen are the reactants and your product is iron 3 oxide. So the first step is to count the number of atoms in each side. So if you take the reactant side, in the reactant side you have iron and oxygen. In the product side you have iron and oxygen, but it's in the formula. In the reactant side you have just 1 iron atom, and when you take oxygen it's O2. Because of this subscript there are 2 oxygens. In the product side you have 2 iron atoms and 3 oxygen atoms. So it looks like either iron or oxygen are not balanced in these both sides, so we need to start balancing the equation. We know that we are not going to change the subscripts, we can only change the coefficients. Since there are 2 ions in the product side, I will add 2 in front of iron. That makes 2 iron in both sides. Looks like iron is balanced. And there are 3 oxygens in the product side, but 2 oxygens in the reactant side. You can start putting 3 in front of oxygen, but that will make 6 oxygens in the reactant side. So that means when you put a coefficient in front of this diatomic molecule, this tells you 3 times 2, there are 6 oxygens. If you have 6 oxygens in the reactant side, now you can make it 6 by adding 2 in front of iron 3 oxide, because 2 multiplied by this gives you 6 oxygens. Now oxygen is balanced. Still, iron is not balanced, because now you have 4 iron atoms in the product side. So we can do is change this coefficient to 4. Now there are 4 iron atoms in the reactant side and product side. So iron is also balanced. So if you write the balanced chemical equation, you have 4 iron atoms will react with 3 oxygens to make 2 iron 3 oxides. This is the balanced chemical equation. Let's look at another example. Aluminum reacts with hydrochloric acid to make aluminum chloride and hydrogen gas. Let's count what are the number of atoms in each side. So your reactants are aluminum and hydrochloric acid. Therefore, you have aluminum in the reactant side, hydrogen and chlorine. So now you have just 1 aluminum, 1 hydrogen and 1 chlorine. In the product side, you have aluminum, just 1 aluminum, and there are 2 hydrogens because it's diatomic, and 3 chlorines. According to the chemical formula for aluminum chloride, there are 3 chlorines. So it's by looking at the chemical equation, you can see it looks like aluminum is balanced. But let's see how we can balance the other atoms. There are 3 chlorines and 2 hydrogens. In the reactant side, you have chlorine and hydrogen together in hydrochloric acid. So if you put 3 in front of hydrochloric acid, that makes you 3 hydrogens and 3 chlorines. Chlorine is balanced, but hydrogen is not. Therefore, we can use a common factor like 6 in front of a hydrochloric acid, which makes 6 hydrogens and 6 chlorines in the reactant side. You can easily make 6 hydrogens by writing 3 in front of H2. So now you have 6 hydrogen. So according to the coefficients, hydrogen is already balanced. Now there are 3 chlorines in the formula. So in order to make it 6, we can put 2 in front of aluminum chloride. That makes 6 chlorines in the product side. Now chlorine is balanced. That makes you 2 aluminums in the product side. Therefore, you have to add 2 in front of aluminum in the reactant side. Now, aluminum is also balanced. So, when you balance this chemical equation, you have 2 aluminums reacting with 6 hydrochloric acid to make 2 aluminum chloride and 3 hydrogen. So this is the balanced chemical equation. This chemical equation has polyatomic iron in it. We have already talked about polyatomic ions when we were discussing chemical formulas. So when you have polyatomic ion, if it is same as in the reactant side and product side, we can use that polyatomic as a one group to balance the chemical equation. So in this chemical equation, in the reactant side you have iron, and you have hydrogen, and also you have this sulfate group. That's the polyatomic ion here. You can still take sulfur and oxygen separately, that is completely fine, but if it is not changing in the product side, you can consider it as a polyatomic ion and it's one group because it's easier. So the products you have here, again iron, sulfate ion and hydrogen. So there is one iron in the reactant side and two hydrogens in the reactant side before balancing, and there is one sulfate group. In the product side you have one iron and how many sulfate groups? So you can see there is a subscript here after sulfate group, therefore there are 3 sulfates, and then there are 2 hydrogens. Now to balance this equation, let's look at how many ions in the both sides. So there are 1 ion in the reactant side but 2 ions in the product side. To make it 2, you can add 2 in front of ion in the reactant side, so it is balanced now. When you take sulfate groups, there are 3 sulfate groups in the product side. Now you can add 3 in front of sulfuric acid to make it 3 sulfates. So whole group here, therefore there are 3 sulfates which balance. And then now you have only 2 hydrogens in the product side, but now once you put 3 in front of sulfuric, it makes 6 hydrogens in the reactant side. To make 6 hydrogens in the product side, you can add 3 in front of H2 because this makes you 3 times 2 with the subscript. There are 6 hydrogen. So hydrogen is also balanced. When you balance the equation, you will get 2 in front of iron, 3 in front of sulfuric, and since you don't have any number here, it's just 1, so you have Fe2 and 3 sulfates plus 3 hydrogens. We usually do not write 1 here in front of iron 3 sulfate, and this is the balanced chemical equation. These are the key points you should know when you are balancing equations. Balancing equations follow the law of conservation of mass. We only change the coefficients, those are the numbers in front of your chemical formulas, and we do not change the subscripts. If you change the subscript, it changes the chemical formula. Therefore, do not touch the subscript. Balance element one at a time. Usually start with metals, then non-metals, and saving hydrogen and oxygen for last. Use whole number coefficients and simplify if needed. We always need to double check that each side has the same number of atoms for every element. Balancing chemical equations is just like solving a puzzle. It may take a little time at first, but once you know the rules, it becomes easier and even fun. And practice makes perfect. If you have any questions regarding balancing chemical equation, please mention them in the comment section. Thank you.